Now that we've compared some of the properties of compounds, we're going to start working with formulas and names of those compounds. So remember, under compounds, we've got two categories. Compounds will either be molecular or ionic. And also remember, on this gridded kind of sheet, we haven't used these since chapter 1, A and B will introduce a topic, and then C and D will kind of follow up and be harder problems related to A and B. So that's going to be our format as we work through these problems. So when we have compounds, the first thing we have to figure out when you have a list of, say, formulas like this, or an ingredient or a medication, is you want to know, is it an ionic compound or a molecular compound? And the way to figure that out is, if you remember, our ionic compounds always contained metals, right? That's why I'm highlighting it, to make that jump out at us. To find your metals, you want to have your periodic table handy. Metals are anything to the left of that brown line, not including the yellows here, right? So anything to the left here. So if I look for potassium, say, you can find that in group 1. It's a metal. Magnesium is a metal. Aluminum is a metal. How about copper? Copper is right here. Copper is still to the left of the line, right? So even though it's in this transition area, it's still a transition metal. So copper is a metal. And then when I look at nitrogen and oxygen, phosphorus and oxygen, here's N and O, here's P and O. They're to the right side of that zigzag line, so those are nonmetals. All right, so once I've identified the metals, anything that has a metal in it is ionic, and anything that doesn't have a metal in it is a molecular compound. So that's always going to be the first thing you want to look at with a formula. Is it an ionic compound? Is it a molecular compound? Now, we're going to see some differences in naming for these as well. And so here it says, consider the names below. How are the names the same as each other, and how are they different? Now, ideal world, we would sit in class and have this conversation. So go ahead and pause the video for a moment and look for similarities and differences in these names, the words here. And then go ahead and unpause and we'll talk through some of the things I saw. So when I'm looking for similarities, you might have noticed, I'm going to underline things that are the same. You might have noticed that there's a lot of ides here. Ide is going to be a common ending, although there are some exceptions, like 8. We'll circle for differences. And then these first element names, did we change the endings of those at all? No, they're all just right off the periodic table, right? So first element, I could say, stays the same in every single one of them. Now, in terms of differences, some things that you might notice, this 8 ending is different. There's also this one Roman numeral that showed up as a difference. And then some of them have these prefixes, these math prefixes, di, tetra, deca. And so those prefixes are different also. So some of the differences that we see this ending of 8. We see the Roman numeral, that 1. And we also see some prefixes. So those are some of the differences that we see. So this is all going to end up tying into this ionic molecular kind of piece. On the other side of the table here, when elements below form ions, what is the charge on each ion? And we want to use the periodic table to determine the ion charges. So we already did this a couple of slides ago. So if you can pull back your slides here, this is where we worked on the charges. And we had said group 1 always forms +1, +2, 3 negative, 2 negative, 1 negative. You can use this sheet, or you can use that same big periodic table from chapter 2 and just write those charges in so it's all in one place. 1 plus, 2 plus, 3 plus. Remember, these share at group 4, and then 3 negative, 2 negative, 1 negative. So now it's all in one place for you. So looking for charges, if I can find these elements on the table, and you're going to start to get really fast at that in this chapter, then I can put a charge on them. So I'm just going to do a couple of them. Lithium is here. Lithium's in group 1, so it's going to be a 1 positive. And then the other element in that row was fluorine. Fluorine's in group 7, so it's going to have a 1 negative charge. So I can put those here. We actually don't usually write the ones. I could just say positive and negative. Okay. Let's look at calcium and phosphorus. So calcium is here, group 2, so 2 positive. Phosphorus is here, group 5, so 3 negative. All right, so all I have to do if they form ions is go look at the periodic table and see what those charges are. So we're forming ions, and all of these first elements that are forming ions are all metals, and then we've got a bunch of nonmetals alongside of those. Now, from those ions, and you can find more here, okay, put the charges on them. We always write the number ahead of the charge. We can use those ions to predict the formulas. And this is something I'm going to write at the top of our pages. From ions, you can go back and forth between ions and formulas. All right, so in a formula, the net charge has to be 0. So if I combine Li plus and F minus, and I look at those, I can think, you know, those will just go right together, a positive and a negative, and I would write LiF. And we do not show the charges when we write that chemical formula. They're there, but a 1 positive, 1 negative add up to 0, and I write LiF. All right. Now next up, the calcium and the phosphide. So calcium 2 plus, P3 minus. Once I have this in a compound, the names are going to change, and there's some names over here for you to look at. So how to name phosphorus, it becomes phosphide, or chlorine becomes chloride. So we have "ide" endings like we saw over here with the naming. Now, I need these to add up when I put them in a formula to 0. So I can't just do a calcium and a phosphorus because those add up to -1, right? So instead, here I have to think through. 6 is going to be a good number to work towards. If I have calcium 2 plus, calcium 2 plus, calcium 2 plus, that gives me 6 positives. And then if I have 2 of these phosphides, that gives me 6 negatives. And so those combine together to give me Ca subscript 3 for 3 calciums, and then P, I'm going to say subscript 2 because I have 2 of those phosphides. All right, so I have a total net charge of 0. Another shortcut way to do that, to get to that formula, is take the charges, or take the ions, and take just the integer values of the charges and cross them down. And essentially you're doing this same math here, but just with a shortcut. So this becomes calcium with a 3 and phosphide with that 2. And notice it's the same answer either way. So you can bring those charges down to help find the subscripts, or you can actually count it out and make sure you have the same number of charges. So I would like you to practice some of these before you come to class and bring questions, or you can check your answers.